Okay, so we've looked at kites before in Unit 2 when we were talking about scalene and isosceles triangles, but now we're going to talk about them in terms of their properties and how we can apply them to solve problems. So a kite has a couple specific properties that we're going to use the most. So the fact that it has two pairs of congruent sides, that we already knew, right? The two short sides and the two long ones are the pair of congruent sides. They also have one pair of opposite angles that are congruent. So here, that would be like angle B and angle D. So those are both congruent in terms of their size. And I know that they're the congruent ones because they're in between different sides, right? Like notice where BA and AD meet, that is not a congruent angle. It has to be between the two different sides. The other thing that I know is that the diagonals are perpendicular. So what that means is where my diagonals intersect, I end up with right angles. That's going to be helpful as well. So when I apply that to a question like number 1, what I know is that I have an 85-degree angle and a 43-degree angle. Now, I'm missing angles B and D, and you'll notice that these two that they give me are not a congruent pair, right? B and D are in between different pairs of congruent sides. So when I'm solving for the missing angle, B and D are actually going to be the same. So here's what I know. It's quadrilateral, and quadrilaterals are supposed to add up to 360 degrees. So let's take away the sum of the angles I have so far. Let's take away 85 and 43. Now 85 plus 43 is 128. So I'll do 360 minus 128. That leaves me with 232 degrees. Now it's not that angle B and angle D are 232, but they have to split 232. So they have to split it evenly, which means each of them would be 116. So now that I've done number 1, you can pause the video and apply the same kind of principles to try number 2. All right, number 3 is a little different. We have to apply a couple more properties of kites to figure this one out. So the first thing that I know about kites is their diagonals are perpendicular. So I'm going to go ahead and draw in some right angles here. Then this turns into problems that we've done before. What I've highlighted in pink is a triangle, and inside that triangle I have a 37-degree angle and a 90-degree angle. Triangles are supposed to add up to 180. So I'll take 180 and subtract away what I have so far. 90 plus 37 is 127. So that's what I'll take away from 180. So far, I know 53 degrees is what's missing. This upper angle in corner Q is 53 degrees. That's all I need to fill in what they're asking me about. Angle PTQ is at the center of this kite. It's a right angle. PQT is the 53-degree angle I just solved for. QRT, well, the triangle in pink is congruent to the triangle that's right next to it. They're reflections of one another. So that means that this corner is exactly the same as what I had already found. 37 degrees. So you can pause the video and try number 4. It's very similar to what I did here, keeping in mind that the two smaller triangles and the two larger ones are congruent and reflections of one another. Okay, so number 5 is just really an extension off of the problem I just did, except they give me 2 angles that I know, and I'm looking for the rest. So to start this problem off, I'm going to use the same principle I did in number 3. At the center of a kite, I have all right angles. I also know that I have 2 smaller triangles I can solve using triangle sum. In the first one, I have a 52-degree angle and a right angle, and I'm missing only one of them. Triangles are supposed to add up to 180, so I'll subtract away what I have inside so far. 90 plus 52 is 142, which leaves me with 38 degrees missing. Angle 6 is 38 degrees. Now, what's special about the pink triangle and the one directly above it is that they're reflections of one another. So now that I know that angle 6 is 38, I know that angle 5 is the same thing. Now that I know the angle they gave me was 52, I know that angle 7 is the same. It's also 52. So that helps me fill in some more unknowns here. When I go to figure out the other 4 angles in this problem, I'm solving this other pink triangle. In that pink triangle, I have a 65-degree angle and a 90-degree angle. I'm missing only one of them. Now, 65 plus 90 is 155, but a triangle is supposed to add up to 180, so I'll subtract that. 180 minus 155 leaves me with 25. If angle 1 is 25, angle 2 is the same thing. If this upper angle was 65, angle 4 is the same thing. They're reflections of one another. So now that I've done number 5, you can go ahead and pause the video to try number 6. It's the exact same problem. 2 triangle sums, and they're reflections of one another. All right, and the last problem on this page is giving us side lengths. So that's where these 2 problems are going to be different from the ones that you've seen me do before. So number 7 tells us that WX is 14 and WR is 8. It wants us to find the length of R to Z. Now, something I know is true for kites is that adjacent sides are congruent. So that means that this side from W to Z is also 14. That's a property of kites. Now, I also know that the diagonals of kites are perpendicular. They create right angles. So you probably have an idea and you're probably sighing of what we've got to do next, because what I'm highlighting in yellow is not just a triangle, it's a right triangle. And it's a right triangle where I know one of my legs is 8, the other leg is what I'm trying to find, and my hypotenuse is 14. So if I start to simplify and solve this, 8 squared plus x squared equals 14 squared. I'm going to need to move the 64 to the other side with subtraction. X squared equals 132. And I only want x, so I need to square root both sides. X equals 11.5. So here, again, we applied the fact that I had perpendicular diagonals and adjacent sides that were congruent to find a missing piece, okay, through Pythagorean theorem. When you try number 8, you're doing a similar thing, except if the full diagonal from A to C is 38, keep in mind that this shorter diagonal gets bisected. So both pieces of AC are going to be 19. That should help you continue to set up and solve number 8.